Now, I'm actually hoping to finish off the lecturing today, believe it or not. So we're still in this topic here of messaging. I want to finish off these slides here. I have extended the deadline for this lab to the coming Friday. So if you haven't already completed it, I'd strongly advise you to do so and get it up. So right, I just want to finish off these slides. Now, I did notice actually when I go into it, there is an issue with the slides actually not coming up, so I need to fix that, but I'll do that offline. So as you know, what we're looking at is filtering in relation to SNS. Yeah, this idea of limiting the number of messages that are sent to particular subscribers. We know that that filtering can be done on the basis of properties of the actual message body itself, or on the basis of properties of attributes that we associate with the message. Kind of covered all that stuff, yeah. The filtering criteria I'm mentioning here, the only one that we've looked at is string-based filtering. It's actually the only one that we will look at, but the other two, although I will show you an example of the third one there, the exists filter. The number-based filtering, it's fairly obvious how it might work. So even though we don't have an example of it, as I said, it's fairly easy to imagine and play with it if we needed to. So the attribute-based filtering, look, I've kind of covered all of that, and it's covered in the lab as well. So I'll skip forward to the body-based filtering, which is where we left off the last day. And the particular use case we were looking at was this one here, this set of architecture, if you like, which is the architecture or similar to the architecture of part of the lab, where S3 is sending messages to SNS, and we've got an SQS, that's a subscriber to it, and we've got filtering going on between the messages that go from SNS to SQS. Yeah, it would be the exact same if we had a Lambda subscriber, we could have a filter there as well. So the way we encode the filtering doesn't really matter whether it's an SQS subscriber or a Lambda subscriber or any other type of subscriber, as it turns out. And for body-based filtering, the key kind of thing is you've got to understand the structure of the message body itself, and you've got to describe that structure in your filtering declaration, and you've kind of got to indicate where within the body's structure are you doing the filtering on, which particular property within the body, because the body could be, typically it's a JSON structure, that's the only one that we're looking at anyway. And the JSON structure might be complex, as in it might be a nested network of objects within objects, which was the case in this scenario here. Yeah. Now, in particular, we said that we wanted to do our filtering based on the name of the file that was being uploaded to S3. Yeah, as you might remember. And I talked over this the last day. This is a screenshot for console log. This is a screenshot, though, of the messages that are SQS. Sorry if I just go back. So the console log is coming from this Lambda here, but this Lambda, what we're console logging are the messages that we receive from SQS, okay, which, as we know, is a batch of SQS messages. But it's really the body within each of those messages. That's what we're really interested in terms of this defining this filter, because it's that body, that's what actually is being received by SNS. The filter is based on the message that SNS receives. It's not the message that the Lambda receives in this particular case, anyway. If our Lambda was a direct subscriber, then it would be one and the same thing, right? The console log of the message from the Lambda that would be here is the actual message that SNS it wants to forward to us, and the filter can be based on that particular message. Okay, so there was a slight complication given that SQS was in here. So when we looked at the body of the SQS messages for this particular scenario, this was the body. So this is the structure of the message. I know now I'm repeating what we went over the last day. This is the structure of the message that that we define our filtering on. And I talked about, when we looked at the structure, it was way down here, this particular property here, that we wanted to define our filtering on, because this part contains the name of the file, and we said our filter was going to be based on the file names that were being uploaded to S3. Yeah. So we've got to define this the structure, and this is how we did it. Okay. So at the very top of the structure was the record key, then we had the S3 key, then we had the object key, and then we had the key called key. And you can see like the value that we're assigning to each of these is always sns.filterPolicy, filteroutPolicy.policy, sns.filteroutPolicy.policy, sns.filteroutPolicy.policy. When we eventually get to the nested part of the structure where we want to actually define our filter, then it changes to sns.filteroutPolicy.filter. Okay, that's just from a syntax point of view. I made the point the last day that the syntax is pretty ugly, but we have to work with it. And the next part then of this declaration is where we actually define our filter criteria. In our case, it was a string filter, and we're using the allow list option, the allow list kind of condition test, if you like, again, which we should know about. So that's really where I left off the last day. Just by way of an example, so supposing we wanted to define a different filter, and if I go back to here, supposing we want to define the filter based on, let's say, this property here, the particular version of the S3 schema, that's what this property is related to. Yeah, we needn't worry about it, right there. Looks like it's the version 1.0 of the schema. So perhaps there was a 0.5 version. We don't really know or care. So supposing we were only interested in messages where the schema version is 2.0, yeah, then this would be the filter declaration. Is it 2.0 I said? Of 2.0, yeah. So again, same kind of story as before, except we're only going as far from S3. We're going to schema version because that is a sub property of the S3 object, and it's a string filter again. So just by way, another example. Now, because body filtering, it's much more from a coding perspective anyway. It's just a little bit more complex, stroke clumsy than attribute-based filtering. So for that reason, in the next couple of slides, I just have a few more examples. I haven't coded these examples, but it mightn't be a bad idea if you just played around with them yourselves, if you actually kind of copy and pasted this code into your own little case study and play around with it. So supposing we've got this other application and we are sending messages to an SNS topic, and these are the structure. This is the structure of these messages. Maria, their user profile messages. Okay, so we've got the structure is a name, an address. An address is made up of these three parts, and an email. Okay, so they're the SNS messages. And let's supposing we've got a Lambda function, which is a direct subscriber, just for simplicity's sake, a direct subscriber to our SNS topic. And we want to do some filtering of the messages that get through to this Lambda. So I've got a couple of examples. The first example is say, let's supposing we only want messages to get through to the Lambda where the address country must be either Ireland, France, or Spain. In other words, this property here has to be Ireland, France, or Spain. Okay, and we can see it's a property within the address part of the message structure. So this would be our filter definition. So again, we start at the top. So the topmost key is the address key, and then its value is filter or policy dot policy. Then within the address substructure, we're interested in the country property. So now we go filter or policy dot filter, because this is the part of the message that we actually want to define our filter. And again, it's a string filter, and it's an allow list, and here is our list of allowed values. So this means that only messages where the address within the, where the country within the address has either that value or this value, only those messages should get through. Another example, let's suppose in the criteria is that we only want messages where the address cannot be Ireland, France, or Spain. So all other countries are acceptable except those three. In that case, we use the deny list string filter condition. So what this is saying is, let every message go through provided its country is not one of these. If it is one of these, do not let that message get through to the Lambda. Another example, again, we're sticking, let's say, with the address. So we're back to where we're only interested in messages where the country is Ireland, France, or Spain. But as well, another condition is that the email address must end in .ie, .com, or .org. So both of these conditions have to apply before the message should be let through. And so here's our filter over here. So again, first of all, we're looking at the address country part, and we have our allow list. And then separately, we're looking at the email part. This here now is not within address. It's obviously separate. And because email isn't broken down into sub-properties, then its value is filter or policy dot filter, because we're defining the filter directly on this top level, if you like, part of the user profile. And again, it's a string filter, but in this case, we're using the match suffix. You might remember there are a number of conditions available to us, condition tests available to us when it's a string filter. There's the allow list, the deny list, the match prefix, the match suffix. I think there's actually another one called contains, but there's certainly match prefix and match suffix. And again, it's an array. You can specify, it has to be an array. Even if it's only one value, you must put it into an array. And so here's our array of acceptable suffixes for our email. Again, from a syntax point of view, you just have to be careful with this, because there's a lot of closing of all of these opening parentheses and curly brackets. That's the tricky part of it, just from a syntax point of view. So that's what that looks like when the filtering policy reads like this. Another example, again, we're saying the country must be Ireland, France, or Spain, and the email must end. Sorry, is that the one we looked at? Do I have that twice? And the email must end in that. Oh yeah, sorry. And the email must end in .ie.com or .org, and it must start with ADM or RES. Doesn't matter what ADM and RES stands for. So so there's both a prefix and a suffix condition associated with the email part of a user profile message. And here's how we encode it here. So you can have a number of conditions within one kind of filter, if you like, if it makes sense. Like up here, I don't think there's any case where it makes sense to have an allow list and a deny list together. Just doesn't, it wouldn't make any sense. But certainly match prefix, match suffix, they make sense okay. So that's how we express it anyway. Getting tired of it now, right? So yet another example here. Country rated, email related, and supposing there's yet another condition where we're saying that the name part, the name property within a user profile message, that has to exist. We don't accept user profile messages if there's no name property. And name property, if I go back to here, right? So name is just another property. But all we're interested in is that there is a name within the user profile. We don't care anything about its value. Okay, so here's how we encode that exists condition. So it's SNS.filter or policy.filter, and then it's just the exists filter. You know, there's nothing else. It's either yes or no. It does have a name or it doesn't have a name. I don't know if it would work even if the name was set to the empty string. It actually would. It would allow it through, I'd say. So, so the reason I've included those couple of examples is so that you can see the syntax for all the different, or most of them anyway, most of the different types of string-based filters. Number-based filters would be kind of similar. And this is an exists filter. Now, that's all I want to cover with SNS, and we've also looked at SQS. This slide here is a slide that we actually saw, I don't know, many weeks ago. And I'm kind of trying to bring us back to why are we looking at these messaging middleware services at all? Excuse me. And you might remember where we began this whole story was talking about avoiding situations where we've got lambdas invoking other lambdas directly, even though it's something we never did, but it's something that you can do. You can have one lambda triggering another lambda. But when you've got a kind of chain of lambdas communicating like that, then there's always going to be the potential for availability issues. Like if one lambda in the chain is not available, either because it has crashed or it is overloaded with work, it's going to impact on the chain of lambdas. So we like to decouple where possible. Sometimes we can't, but we like to decouple that kind of interdependency between lambdas in a chain. And that's where we introduce these messaging services. There's a third type of messaging service called data streams that I just want to briefly look at. This is also a slide you might remember when I looked at Lambda on day one, which is now way back around week 4, I guess, or something around then. And we talked about the different integration models for Lambda. By integration models, we mean how other services can trigger a Lambda. And there were three integration models, if you remember: synchronous, asynchronous, and pole-based. With synchronous, an example of synchronous integration was API gateway. So when an API gateway sent a message to a Lambda function, the gateway waited for the Lambda to respond back with the result. So there was synchronous communication between API gateway and our Lambda function. Asynchronous, an example of that is actually SNS, because when SNS, we know, and I've talked about this in more recent weeks, SNS really sends the message onto the Lambda service, and it doesn't wait for the Lambda service to actually trigger the Lambda function itself. Once SNS has delivered the message to the Lambda service, then it's out of the equation. Therefore, it's not communicating directly or synchronously with the Lambda function. Hence, the connection between SNS and your actual Lambda function is asynchronous. The third model is, strictly speaking, it's referred to as event source mapping. Okay, I kind of refer to it as pole-based, which is slightly easier to understand. And that's what we had with SQS, if you remember. Now, another scenario where this pole-based integration model applies is with data streams. And in the image here on the right, the idea is, so you've got some sort of client talking to DynamoDB, and it's making state changes to your DynamoDB table, adding new items, deleting items, updating items. Yeah, you can get DynamoDB to maintain a stream of all of the state change events that are occurring within a table. So it generates this stream. Now you can use that stream as a stream of events for a Lambda function to process. And the way it actually works is similar to SQS. What actually happens is the Lambda service periodically polls the DynamoDB, asking it, do you have any new entries in the stream for a particular table? DynamoDB will respond with a batch, potentially, of stream events. And then the Lambda service kind of maintains an internal data structure, which I'm showing here as a queue, but it's just an internal array, really, if you like. And the Lambda service, just as with SQS, the Lambda service takes care of invoking the Lambda function and passing that stream to the Lambda function for processing. So typically over here, this is a Lambda. So rather than this Lambda here communicating directly with this Lambda, it's actually going via the DynamoDB table service, or DynamoDB service, I guess. So I just want to show you from a coding point of view. We won't have a working example. I'll just show you excerpts from the code as to how you set up this integration between your Lambda function and your DynamoDB table. So the steps are, number one, declare the stream in the table. So essentially kind of tell DynamoDB, maintain a stream of state change events for a particular table. You do that at the table level. Secondly, declare that stream as the event source or the trigger for a Lambda function. Right. So it's typical kind of stuff, really. Console log. Well, this is always a good idea. You know, it's always a good idea to. I mean, you'll have seen now at this stage that every single Lambda that we've looked at, the very first statement is a console log of the event object that's passed to it, and because we need to find out what is the structure of these stream events that are being passed in in batch mode to our Lambda function. So we'll just console log the event to do that. I don't think I have actually got a screenshot of it, but that's okay. So in terms of step one, all we really need to do in our table definition is set this property here, the stream property. And we can set it to essentially what we've got to tell DynamoDB is how much information should be put into each stream entry in the, each stream entry. So I'll come back to this a second. So we're sort of declaring what type of, the stream type. And I'll briefly talk about the different types. I think there are 4 different types. But the net effect anyway is it's indicating how much information should be put into each stream entry. So that takes care of telling DynamoDB to maintain the stream. And here is how we hook up that stream to a particular Lambda function. And the coding for this is actually the exact same as when we were hooking up a Lambda to SQS. Okay, we're simply making the stream the event source for a particular Lambda. Is that? Sorry, I'm just checking. Oh yeah, that's so this obviously is the name of some Lambda function, which I haven't shown on the screenshot, but this is a reference to a Lambda function that's defined elsewhere in my CDK stack. I'm adding the event source. I'm saying that the event source in this case is a DynamoDB stream. Now, I just noticed this actually a while ago. What I should have here, this here really should be a reference to my table. So it's the wrong name. Up here, I've called the table my table. Down here, I'm referring to it as review table. So they need to be the same name. So I've obviously cut and paste these from different CDK projects that I have, and I didn't spot that. And that's it, right? So step one is here. Step 2 is this, simple as that. Yeah, I said there, right, there are different types of streams, as in how much information should be put into the stream. And these are the 4 types. New image, new and old image, keys only. New image means that I only want to, I only want the state of the new state of the particular item that has been changed in the database. Yeah, because remember now, the stream is a set of logs of state changes, and so there is a log per state change per item in my table. So I only want to see what is the new state. Sorry, this one here, I only want to know about the new state of the item. Here I'm saying I want to know about the new and old state, sort of the current and previous state. So presumably my Lambda function that's going to be doing the processing of that stream, it's doing something with both the new and old state. Here I'm saying I'm only interested in the old state, so that it's only the previous state of the particular table item that's recorded in the stream. And this one here, I'm only interested in actually the keys, as in the partition key and sort key, if there is a sort key. They're the only things that need to go into the stream. I don't care about the other attributes of the item. Yeah, so, and again, so for example here, or not for example, like as we're typing this, creating this code here, when I hit the dot, then here, look here, the four options that are available to me, which I'm itemizing here. Now, as I said, I I don't actually have screenshots of what the different structure, uh, what the different structures are for these, but they are what they are, right? What am I saying here? A stream entry. Oh yeah, the other thing that's included in the stream entry is what was the nature of the event, of the state change to the item? Was it a new item that was added? Was it an item, an existing item that was updated? Or was it that an item has been removed from the table? So more than likely your Lambda function would need to know what was the nature of the state change. As in, was it new item, a modified, an existing item, or an item removal? It may or may not need to know that, but it's in the stream entry anyway. And I think, sorry, one more slide. Well, look, all I'm saying here, telling you here about is what are the different in the actual Lambda function itself. The type of handler it is DynamoDB stream handler, as opposed to an SQS handler or an SNS handler, or even the handlers that we had way back when we were looking at API Gateway. I can't remember what the name of that handler was, but it had a name that reflected the fact that it was a handler for receiving events from API Gateway. In this case, the handler is of this type. And in your stack file, these are some of the imports that you would need to include in the stack file. Because, for example, this one here, we need that because if I go back, we're using it here. And similarly for this one here, yeah, we need to import that, and I'm just giving you all the imports there. As I said, I don't have a working example of this at this stage. Now we've seen so much Lambda functions and Lambda handlers that it wouldn't be difficult for you to whip one up yourselves if you needed to. And that is my last slide. So I have effectively finished lecturing at this stage. Let me go back to here. Yeah, and unfortunately, though, for ye, I guess there is the small issue of the lab-based exam, which hopefully you've read the message that I sent out there on I sent out this morning, and I've included a link to a GitHub repo. Now, you may not have had a chance to look at it, so I can certainly accept questions right now on it, but what I can also do is on Thursday, I'll just talk a little bit about that to you. But I'm happy to accept questions now if there are any immediate questions that you have for me.
For the exam, is it an open book exam or?
Yep, it's open book. You can access all of the labs, any of the code that we've produced during the semester. It's open book. You can access this website. Obviously, the only thing you can't use are any type of AI tools. But other than that,
Are you allowed to use search engines?
yep, you can.
Okay.
Yep, everything except AI.
Okay.
Yeah. I can tell you that it's predominantly based on this messaging stuff that we've been looking at, but obviously, there's going to be lambdas in it as well. So we started looking at lambdas way back years. So lambdas are in there. DynamoDB is in there as well. but there's nothing on API gateway. So it's all this messaging stuff. I can tell you that there are 5 questions. Sorry, well, I was going to say I was going to leave this on Thursday, but we've got a few minutes, so I'll keep going anyway.
Yeah. Okay.
You will start off with the repo that I gave you this morning. You make a copy of that into your own GitHub account, clone it, etc., etc. That'll be your starting point. Then the exam will have 5 questions where you'll be essentially just adding code to that project, and you will be submitting that as your solution, if you like. There are 5 questions in the exam. The exam will be for 2 hours. It'll be for the duration of what was normally our lab period. There are 5 questions. All 5 are mandatory. And that's about it, really, I suppose. That's probably what I was going to be telling you on Thursday. Although I do need to just quickly skip through some parts of the code just to maybe clarify 1 or 2 things. And again, give you an opportunity to reflect on the code and maybe formulate other questions for me.
Thanks.
Anything else?
Diarmuid, would there be any like practice, like exam kind of that you had some similar like last semester? You showed some practice,
I'm not sure what you mean by practice exam now.
like a kind of like a practice exam, so we know kind of what to expect, kind of like a small one.
Or instead of preparation, is it?
Yeah.
Well, I'm hoping that giving you this starting repo, which you can study. Well, the short answer to your question, I suppose, is no. I don't remember having a practice for last semester's exam either, so I'm not sure. But either way, I'm hoping that by giving you the starting code, and by outlining what I've just outlined to you now, and maybe explaining 1 or 2 parts of the code, clarifying 1 or 2 parts of the code, and having walked through this lab, I'm hoping that should be enough preparation. I'm not sure what more I can do for you. You know?
Yeah, that's fine.
Yeah. Any other questions?
So is it next Friday, is it?
So it's essentially next Friday week, not this Friday, the following Friday.
Okay, yeah.
Yeah, 1st of May.
Okay, thank you.
1st of May from 11:15 to 1:15 in IT 118. Actually, I must make sure I've got the right room actually. And it'll be a bit like last semester. I'll have a 5G modem. You'll be using that. You'll be deploying to AWS during the lab a couple of times probably. Well, there are 5 questions, so a minimum of 5 times. I will be telling you this anyway, but make sure you've deployed the stack initially before the exam, because there is a DynamoDB table in it, and there is seeding data for that table, and that can be slow. So you just make sure that you have deployed the application before the exam, and then you'll just be updating that deployment a couple of times during the exam, as well as you'll only be pushing. You only need to push to your GitHub repo at the end, although you certainly will need to be committing locally. And a bit like in last semester's exam, I tell you exactly when to commit and what to commit. So that's critical that you have a Git history. Anything else? No.
Do we have class on Thursday then? Or
Well, I will have a Zoom session. I'll just briefly explain 1 or 2 things in the report that I gave you. In particular, just the the TypeScript types that I have defined. I mean, the stack file is pretty straightforward. The lambdas are skeletons, so there isn't much in that. So it'll probably be only about 5 or 10 minutes at most, I'd say. And if you can't attend, then it'll be recorded, so you can look at it if you need to. So it may, the more I talk, the less significant it's probably going to be. But I will open a Zoom session because people may have one or two other questions. As for next week, again, I'll open up a Zoom session, but if there's nobody there, that's fine. Okay, that's it. Bye for now.